So hello everybody, welcome to our second lesson. In our first lesson we discuss what is an atom, what are the subparticles, okay, and what are their locations and their functions as well. So in this lesson, let's get started with learning objectives. These are our learning objectives. As you see that we are going to define what is atomic number, what is atomic mass, what is an isotope, and how to calculate relative atomic mass of isotopes of an element. Okay, so in our first presentation here we can start with the definition of atomic number. So atomic number can be defined: total number of protons or positive charges in the nucleus is called atomic number. So we will say atomic number, total number of positive charges is called atomic number. We know that protons or positive charges are fundamental particles of an atom. That's why these positive charges are available in every nucleus of an atom. So the total number of these positive charges are called atomic number. Okay, every element has an atomic number, and this atomic number is unique. For example, here we have example: atomic number of oxygen is 8. Okay, atomic numbers can be represented by capital Z or small p. That is also important. So capital Z and small p is the symbol, or we can say that the symbol of atomic number. Okay, so every element has atomic number, as I said. So for example, these are the example: atomic number of oxygen is 8, atomic number of sodium is 11, atomic number of carbon is 6. Here I have periodic table. I would like to show you. Okay, you can see in this periodic table, so every atom has atomic number. For example, atomic number of hydrogen is 1, atomic number of beryllium is 2, atomic number of lithium is 3, atomic number of boron is 5, atomic number of oxygen is 8, atomic number of zinc is 30, atomic number of chlorine 17, atomic number of argon 18. So here you can see, in this periodic table, you can see that elements are organized according to their increasing atomic number. It means that elements are identified or placed in the periodic table by increasing atomic number. That is very, very important. Every element has an atomic number, and as I told you in our previous video, so two elements may not have same atomic number. Suppose neon. Neon has atomic number 10. It means that there are 10 protons in the nucleus of neon, and neon the only element which has exactly 10 protons in its nucleus. Okay, so this atomic number is important. Once again, let me say atomic numbers is define the total number of protons or total number of positive charges which is available in the center of an atom. Okay, so our next video is term is atomic mass, means mass number. So mass number is total the number of protons and neutrons is called mass number. Okay, as you see that mass number is defined the number of nucleus. It means that total number of proton and total number of neutrons in the nucleus is called atomic mass, and atomic mass is represented by capital A. So there is a formula in that. According to that formula, atomic mass is equal to total number of proton plus total number of neutrons. Okay, please don't forget this formula, because we are going to use this formula. As you see that here also, protons plus neutrons is equal to atomic mass. Once again, I am going to repeat: atomic mass is equal to proton plus neutrons. Proton plus neutron. It means total number of positive charges plus total number of neutrons. Okay, this is called atomic mass. Here I would like to ask a question. Since, as we know that an atom has three subparticles: proton, neutrons, and electrons. As you see that proton, neutrons, and electrons, and they have also mass. Each particle has mass. Okay, so according to this information, atomic mass should be proton plus neutron plus electron. So why we don't add electrons in atomic mass when we calculate atomic mass? Why electrons, the mass of electron or the mass of an electron is not considered? So actually, as we studied from our previous class, we said that one proton is almost 2000 times heavier than one electron. It means that the mass of electron is almost negligible as compared to mass of proton and neutrons. That's why we are not going to 8. Suppose I can say I am like 80 kilograms, okay? If there is a mosquito, I come and stay, or we can say that stay on my shoulder. So my atomic mass is going to change definitely, but the mass of mosquito is like I can say 0.0001. So when we add total, I am going to add almost like 80 atomic mass. It means the mass of mosquito is negligible as compared to my mass. Okay, so here in the periodic table, let me go to periodic table. You can see that elements in a box, I can say like in this box you can see there are information, like you can see the symbol of an element. We have a symbol. Every element is represented by a symbol, like hydrogen is H, sodium is Na, oxygen is O, okay? And in these symbols, they are the symbols of elements, and okay, elements are represented by the symbols. So there are some places which is important for us. For example, X is an element, okay? Always atomic mass is written on the above, on the right side of this area, okay? This is the place for atomic mass. Almost it is like this, atomic mass, okay? And proton number, total number of positive charges, Z or small p, is always written on the, okay, left side, but the opposite of atomic mass. And between them, always the number of neutron is always written in between them. And once again, let me remind you, atomic mass is equal to total number of proton plus total number of neutrons, okay? That is important, and you can see that in this example, atomic mass is written on the right side above, okay? The X is the symbol of an element, and you can see number of neutron is written between atomic mass and atomic number, and atomic number is represented in the below, opposite of atomic, okay? Atomic number is represented below and opposite of atomic number, okay? So here we have another condition. It is very important. Atom is naturally, it is neutral, okay? Atom is naturally neutral. So when atom is neutral, we must know that the number of protons are equal to number of electrons, please. In which condition? When atom is neutral. When atom is what? Neutral. The number of protons are equal to number of electrons. We shall not forget. Total number of positive charges are equal to total number of negative charges. In which condition? When atom is neutral. Okay. Now here I have an example. In this example, you can see that an atom has mass number 39 and atomic number is 20. Find the number of neutrons in the nucleus. Okay, so according to information which is given to us, you can see there is an X, okay, X an element, suppose, and okay, it has atomic mass L is 39, and it has also atomic number. Atomic number means P or capital Z is 20. It means there are 20 positive charges. So they are asking what is the value of N, means number of neutrons. So as we know that atomic mass is equal to P plus N. That's why 20 is atomic number, 39 is atomic mass, plus N. N is equal to 39 minus 20, N is 19. So the number of neutron is 19. Okay, as you see that in here also it is written atomic mass is 20, atomic mass is 39, atomic mass is 20. According to formula, when we put the value, we are going to get 19. So in our second example, in this example you can see a neutral atom has mass number 40. Okay, let me write. Okay, there is a neutral atom. Okay, like I can say that X is neutral atom. It has a mass, atomic mass is 40, and the number of electron is 20. The number of electron, how many? 20. Okay, so the option A, state atomic number. What is the value of P or capital Z? According to information, as we study, when atom is neutral, I know that protons are equal to electrons. So since we have the number of electrons, that's why electrons are 20. that is equal to number of positive charges because atom is neutral. Neutral means you may think like this: atom does not have any electron, does not lose any electron, or does not gain any electron. Okay, so it doesn't have any positive negative charges. We are gonna study in the title of ions. Okay, option B, calculate the number of neutrons. Calculate number of neutrons. I know that A is equal to P plus N. P plus what? N. I know A is 40. I have already find the value of P, that is 20 plus N. N is 20. Now I have two more examples. You can see that calcium, the value is given to you, the sum, like the values are given to you like 20. I told you in this side always atomic mass is written here. Okay, here the number of neutron, and here we have proton numbers. Okay, they are asking the value of N. I know that A is 20, P is 12, so N, what is the asking me? So according to information or formula, A is equal to P plus N. So we are going to find 20, okay, so sorry, 20 plus, so 20 is equal to 12 plus N is equal to 8, okay. In second example, you can see they are asking what is the value of A. I have the number of neutron, I have the value of proton, so I know that A is equal to P plus N. P is 11 plus N is 12. The value of atomic mass of sodium is 23. Okay, these are the example. Okay, you can find the more example. Now here we are going to define, okay, isotopes. How I can define isotopes? So you can say that isotopes in the periodic table, almost all the elements, they may exist, okay, with different atomic masses. They may exist how? They may exist in different atomic masses. Suppose I can say the carbon has, normally the atomic mass of carbon is 12, but there are some also other isotopes of carbons. Some of them they have the mass of 13, some of them they have the mass of 14. So you may ask, are these different elements or these are the same elements? Actually, for an element, we are going to consider atomic number. Okay, if the atomic numbers are same, these elements are same. I know that atomic number of carbon is 6, 6, and 6. So that means these are same elements, just physically they have different weights. Okay, they have different masses. These are the same elements. So as you see that isotopes of an element share the same number of protons but have different number of neutrons. Since we know that atomic mass is equal to P plus N, okay, if the P is equal in all the elements, so atomic mass, the N should be different. Okay, as you see that they must have same atomic number but different number of neutrons. That's why they have different atomic mass. Protons are equal but neutrons are different, so they have different atomic masses. Okay, I am going to give an example. On example you will see. So the chemical properties of isotopes are identical. It means that the chemical properties of isotopes of an element are almost same because these are the same element. They have just different atomic masses. I am going to give you some example. On that example you can understand better. For example, in the periodic table, okay, almost all the elements they have isotopes. What does it mean? They can exist in different atomic, in the form of having different atomic masses. Okay, here I have, okay, like hydrogen. Hydrogen can exist in different atomic, can exist in different form, like form of having different atomic masses. So you can see that we are going to find, as you see that in this hydrogen, which is called protonium, the atomic number is 1. Okay, atomic mass is 1. So when I calculate atomic number of neutron, A is equal to P plus N. A is 1, P is 1, so N is equal to 1 minus 1, 1 minus 1 is equal to 0. So you can see the number of neutron is 0. When it comes to deuterium, P is almost also same because these are the same element. According to definition of isotopes, they have same atomic number but different atomic masses or different number of neutrons. So the value of N A is 2, atomic mass is 2. According to formula, P plus N, 2 is equal to 1 plus n is 1. Okay, if it comes to tritium means P is also 1, okay, so A is also 3. According to formula P plus n, we can see 3 is equal to 1 plus n is equal to 2. So as you see, my dears, here isotopes of hydrogens, they have same atomic number 1, 1, 1, but they have different atomic masses. Because due to the different number of neutrons. So I can say hydrogen, the proton number of H1, H2, H3, let me write 1, 1, 1, okay, but number of neutrons are, one of them is 0, one of them is 1, one of them is 2. So as we know that atomic mass is equal to m plus p, 1, 2 and 3. So once again, when we define isotopes of an element can be defined having same atomic number but different atomic mass or different number of neutrons. Okay, these are the example. Another example we have, okay, for example, carbon. Carbon in the atmosphere, it may exist in different form of having different masses. Okay, carbon which has 12 atomic mass, carbon which has 13 atomic mass, carbon which has 14 atomic mass. That is important. Okay, so the proton number of carbon is 6, 6 and 6, as you see that. So one of them has 12 atomic mass, another one is 13 atomic mass, and other one is 14 atomic mass. So what makes them different? Of course, due to having different number of neutrons. Here the number of neutron is 6, here the number of neutron is 7, here the number of neutron is 8. So you can see these are the isotopes of carbon. Okay, so here I am going to explain like this. You can see in this picture also you can see carbon which is having 12 atomic mass, carbon which is having 13 atomic mass, carbon which is having 14 atomic mass. So atomic number is same, 6, 6, 6. When we calculate, you can see number of neutron is 6, number of neutron is 7, number of neutron is 8. Okay, here you may ask a question. Okay, so you can see what is this 1%, 98.9% and 0.0001%. Actually, just you think like this. Okay, these are called abundance. Abundance means how much this carbon atom is available in the atmosphere, which is having 13. How much this carbon 12 means carbon atomic mass 12 is available in the atmosphere. Abundance means how much carbon 14 means carbon which has 14 atomic mass is available in the atmosphere. So you can see when we compare, my dears, the carbon which has 12 atomic mass is almost 99%. Yeah, like we can say if there are 100 molecules, okay, 99 molecules is carbon 12, just one molecule is carbon 13, and almost 0 molecule is carbon 14. So when we write, so you may ask a question, okay, in the periodic table, which one, okay, which atomic mass is written? When we go to periodic table, I want to show you. In the periodic table, let me go and find, this is the periodic table. Okay, where is the carbon? Okay, carbon is here, but you cannot see, but I can see the atomic mass is here. Let me magnify for you, 12.001. It means that almost the one which is available most atomic mass is near that one. Like which one? That is carbon, of course, carbon 12. You can see that in the periodic table. So I am going to show you how to calculate atomic mass of the isotope of an element. Another example is, my dear, oxygen can exist in different forms, 3 different forms: oxygen 16, oxygen 17, oxygen 18. Okay, these are the isotopes isotope of oxygen. Okay, atomic number is 8. It doesn't change. 8, 8, 8. It means there are 8 protons. These are the same, but they have different atomic masses due to having different. Okay, due to having different number of neutrons. Okay, these are another example. So you can see it is that. Here I have another example, okay? Chlorine. In the periodic chlorine has two isotopes, okay? One chlorine which atomic mass of 35, another chlorine, okay, which atomic mass of 37, okay? How about their abundance? In the questions, the chlorine which has 35 atomic mass, 75%, okay? In the earth, 75% of the chlorine which had 35 atomic mass, and 25% of the chlorine, okay, which has 37 atomic mass. So which one is written in the periodic table? In such cases, we are going to take relative atomic mass. What is relative atomic mass? Relative atomic mass can be calculated like this, okay? It can be calculated like this. How? The mass of the first isotope multiple percentage means abundance plus the mass of second isotope multiple another percentage divided by 100. We may think like this: if there are 100 molecules, 75 molecules is chlorine 35. It means that 75 atoms or particles are having 35 atomic mass, and 25 particles are having, okay, 37 atomic mass. So when we calculate like this, you can see 75 multiple 35. 75 means abundance percentage, 35 means the mass, okay, and another 25 mass, so 25 percentage multiple 35 atomic mass divided by 100. So atomic mass is 35.5. When we go to periodic table, let me show you. When we go to periodic table, you are gonna see that exactly atomic mass of chlorine, where is it? Here. You cannot see, but I can see 35.5. It is not whether 35, it is not whether 37. So the isotopes, the relative atomic mass of isotopes of an element can be calculated by this way. Here I have the last example. I am going to give you one more example to make it clear. Okay, for example, iron, my dears. Iron has 4 isotopes. One of them, iron with 54 atomic mass, the abundance is 1.82 percentage. Another one is iron with 56 atomic mass. Abundance means percentage is 91.66, okay. Another one is iron, I have, okay, 57 atomic mass. So the abundance is, what is abundance? I can tell you 2.19. And finally, the iron which has 58 atomic mass, abundance is 0.33. Okay. So which one is going to be written in that on the periodic table? Of course, no one is going to be written. We are going to take relative atomic mass. Relative atomic mass will be nearer to 56, because you can see that the mostly 91% of the particles are having 56 atomic masses. So relative atomic mass is how we are going to calculate, as I show you. The mass of 1, 54, multiple abundance 5.82, plus mass of 2, 56, abundance 91.66, plus mass of third isotopes 57, multiple 2.11, and plus the mass of last isotope 58, multiple 0.33, divided by 100. When we are going to find 56.5 will be the atomic mass of iron. Okay, so this is the end of our lesson. Thank you very much for watching, and see you in our next part. Okay, have a nice day and stay blessed.